I've cleaned up my traces. I tried to separate the power wires from the gate drive. I had to add some external capacitance across the gate source there. So that's what these capacitors right here are. The shunt capacitor is 3 nanofarad or so, like 3.2. It's down there. A tiny little board sticking out. Those are little baby multi-layer ceramics, which are pretty damn amazing. After doing that, I seem to have damped the ringing enough to where I can feel comfortable to crank this up and push the power that I really wanted to from the beginning. So what that extra gate capacitance has done was it increased my rise time a little bit, same with the fall time, and I end up with these undershoots that were quite a bit larger than what they were before, with only the reverse parallel diode on the external gate resistance. Now they're swinging a little bit lower, about 2.5 volts or something like that, which is fine to me. I think it's actually a good thing. But by getting that just right, then the ringing that occurs actually gets damped enough to where it fizzles out a little bit quicker, but it also doesn't ever really reach, like a hair over 2 volts. So that's what I want. I don't want it at all, but what I don't want it to do is reach the threshold voltage, which is something like 4 volts. So as long as it stays down there through the whole swing of voltage ranges that I want, then I feel like that's fine. So that's what I ended up with. Crank this up a little bit. Still about the same operation was before. So get that going. And I've also retuned it to where that primary can sit just like a smidget higher, which allows me to push more power, or closer to like a couple hundred watts or so, like I wanted to. So let me go ahead and kind of zoom in there. So just kind of keeping an eye on the ring in there. So I'm looking at the positive peaks there, and I'm on 2 volts per division, so it's only less than a volt right now. And keep cutting it up. I'm gonna put it at 40 volts. Get it tuned about right. So at 40 volts now, 175 watts. See that ringing is still below about 2 volts. So that's kind of what I want to see there. That's how it's switching now. Alright. 175, and that's tuned a little bit above Class E. So then when I start loading it like that, or pulling the arc, when I pull the arc, start switching pretty good. And the ringing goes down a little bit also, as you can see. So I'm gonna cut up a little bit more, do 45, 210 watts. All right. So running it like that obviously is not bad. About 46 volts for some amps. About 200 watts. Can't really see that. I like that. I can deal with that. All right. So cut that off. And this heat sink right here, it's not a very big heat sink, but it is warm. It'll be a while before it gets hot. If it does get hot, it probably would after a while, but you got to be realistic. Probably put a little fan, or maybe use a bigger heat sink, but there's no way I could run that with something like a 460 or maybe even a 260. This heat sink would have been blazing hot a long time ago. Just because you can get away with good switching doesn't mean you should just totally drop the heat sink altogether. The cooler you can keep it, the better. So either way you want to heat sink. But again, just man, barely any warmth on there, and I feel like the 650 volt version would have worked even better. Here goes the capacitors, by the way, my shunt capacitors. Look how tiny them damn things are. Smaller than a grain of rice. So yeah, there's a 400 volt stacked parallel or series parallel bank. Ended up being about 3 nanofarad. I've always loved this effect. I don't know if I can get that show up better. Yeah, that effect where it's just barely like just a hovering cloud. That plasma. If you bring it too close, then it's going to start jumping to an electrode.